So, hi everyone, welcome to this session. My name is Cesar Garcia, and I would like all of you to learn more in this tutorial about open data quality, and how to use some Python tools like Grid Expectation, SweetBees to make the most out of the data quality of this dataset. For the last years, I've been working really hard on open data and how to make the most of the data that is available for everyone to use. And sometimes there are like nasty problems with data quality in these data sets. So I like to just go ahead and share this tutorial session so all of you can learn how to use these tools to assess the quality of the on open data dataset, and then find out if you can improve certain aspects of the dataset to make it more useful, or to fix some problems that prevent you from doing some data analysis task, or just to research about open data expenditures, or whatever is your topic of choice. There are so many things that are going on in open data. So there is at least 10 to 10,000 data set that might be useful to whatever you are trying to lean towards. So I see there are some people coming to this talk. I'm really happy to welcome you all. And now we're going to start this tutorial session where, like I said, it's going to be quite hands-on. Before I start with the technical aspect of the presentation, this is kind of the agenda for today. We're going to be talking about open data and open data quality concepts for the first 10 to 15 minutes. So you can learn more about what do we mean when we talk about data quality, that maybe it's a bit abstract concept. Then we'll spend most of the session on validation of single data sets. How can we just take a data set from an open data source and then just transform it into something that is better than the one you got from the internet or for whatever portal you got it. Then we will spend around 20 minutes doing the preparing longitudinal data. How do we get this year over year data set so we have the same data and the same format for all the years involved? And then we will just keep the last 10 minutes for the Q&A. So if you have any question, just feel free to drop them in the platform, and the host and the co-host will help me just putting them on screen and getting them solved as soon as possible. So what tools are we going to use today? We are going to use Grid Expectations, we are going to use Pandas and SweetBeats. I assume most of you attending PyData Global Conference are very familiar with Pandas, but maybe you are not so familiar with the other tool presented. So by the end of the session, I expect you to be able just to use these tools on your day-to-day tasks to improve the data quality and to do the exploratory data analysis task. So before we move further, I would suggest you, if you want to go along with the session and want to try things on your own, there is this repo. I'm going just to copy and paste the whole URL in the chat. So if you just want to, there are kind of two options. Either you are going to run it on your local PC. For me, that's the best way to run it. Like just clone the repo and create everything on your local PC, and then everything works. The data is already included here on the repo, and you don't have to download anything extra. But other than that, you can also try to run it in Colab, and these are kind of the steps. You need to open colab.research.google.com. The file menu, just go and open notebook. This is in Spanish, so if you are following other languages, it's open notebook. And then you will have the GitHub. Well, this is kind of the issue with the Colab time, that if you don't write for a while, maybe it will time out and then you will need to reload it. But if you click here on the single data sets, this is a Jupyter notebook, and you will be able just to run the whole experiment. And there is a cell just for Colab users, because like I said, whenever you are opening the data set, you need to install your requirements, and you need to install kind of everything. And also you need to download manually the data set we're going to use. If you are running this locally, you will have no issues. Just go in there and running the Jupyter Notebook from the start to the end. So what are we going to do today is kind of explore open data and figure out what is the quality and how to make it work for you. So one little, I wrote a note, so I didn't forget about it. So grid expectation is not officially supported on Windows, but it works. I mean, everything you will be seeing today is running on Windows, and the thing about Windows support is mostly related to the problem of being able to pop up new windows from the browser, and this is something that is not really consistent on Windows. So this is the reason that one of the reasons that grid expectation is not officially supported on Windows. So your mileage by depending on the source. So Alessandra has just shared the link to the repo. It's going to be pinned on the chat window. So if you want to go along with the coding session, it's going to be really nice. Just follow the instruction, just follow the README, and you can do this while I go on with the next steps. So let's do a brief introduction about grid data quality, because usually when we talk about data quality, there are so many perspectives. Everyone has their own vision of what is data quality, their own ideas. And I like to introduce the basics so all of us have this kind of common knowledge, this common vocabulary that will help us like do it better. So in a summary, what this talk is about is like, okay, we all of us know pandas or know how to do some data cleaning, but well, there are some standards, there are some manners, there are some established ways to measure data quality. So there are some international standards like ISO 25012 that deal just with data quality. So even though we are going to see pandas, we are going to try to frame how pandas work inside this kind of standards base. So we are not reinventing the wheel. We are just pushing forward and standardized quality for all our data sets. The more people just share kind of this knowledge and the same framework, the easier it's going to be to move forward. So whenever we approach a new file as Python users, usually we load pandas and we start firing like, okay, let's figure out if there are duplicates. Let's figure out if there are nuns. Let's figure out if any column is kind of empty. Let's just set the correct data type, because maybe you're just typing and there's, oh, this was imported as an object. I want this to be a data time, whatever. There are a lot of functions that can be used to do this data cleaning, but most of the times this is not standardized. Most people do not have like a clear set of steps just to move forward. It's more like, okay, I want to try these 2, 3, 4 things, and whenever it looks okay, we move forward with the analysis. And then later on we find the problem that, oh, then we discover another problem, then we have to go back, fix it again, go back. So I'm just trying to avoid this kind of one shot where you go ahead and say, okay, I'm going to fix everything manually. I'm trying to promote another approach that is kind of more rigorous. So if you want to know more about these international standards, you can kind of read on these ISO notes or on the Data Management Association, the book. And even there are some new standards in the laws in the European Union for the artificial intelligence law. There's tons. If you are a Spanish speaker, you are very fortunate, because the National Standardization Office has just published these guides in English, and by the time we are having this presentation, these are available for free. So if you want to learn from the actual standards, they are available for you to move forward. So what do we mean by data quality? So the data quality of a data product might be understood as the degree to which data satisfy the requirement defined by the product owner organization. This looks very nice, but might not be really easy to comprehend. So my short definition is what is the extent to which the data characteristics are fit for purpose. And you may say, what do you mean by data characteristics? What are the characteristics? So let's take a sidestep and look at actual non-data example. So if we were choosing a shoe and we were like trying to say, oh, this is the optimal shoe for me, is this really nice? We might just start creating a table or drafting like, okay, there are some features related to the spatial, to how the shoe is, it's the material aspects. For example, what is the size, and maybe this is the length, the width. Maybe there is also an angle. So if you don't step like really flat, you might need some correction. And then there are the materials, and you have to find out what is the optimal shoe for me. And of course, you will need a certain length, a certain width, maybe a certain angle. But if we take a step back from this optimal shoe, there is not such an optimal shoe. There's optimal shoe for a particular purpose. So whenever we're dealing with data, we also need to ask the very same question. What is what are the needs? What do I need data to be for me to be able to do an analysis? Otherwise, you are all the time trying to find the perfect data set that maybe doesn't exist. So it's very interesting to ask yourself, okay, whenever I'm dealing with this data quality that has all these kind of properties, metrics, characteristics, what is our purpose? I am trying to do some check and balances to my government. I'm trying to find out what are the spots where most traffic accidents happen. Maybe I'm a biker and want to find the best routes in my city, so this street that have the less accident ratio compared to other streets. Whatever, whenever I'm approaching a data set, I need to figure out what is the purpose, what do I want to analyze, because depending on what you're trying to do, maybe the data set is optimal for you, or maybe you need some extra adjustments. Adjustments in what kind of dimensions, you might be asking and wondering. So when we are talking about these characteristics, they're like kind of in the ISO 2512. There are kind of um, two different fields. Some of the characteristics are inherent of the data set. So if you get the data set, everything you need to calculate, everything you need to figure out, it's in the data files themselves. Other than that, there are other features that are dependent on the system. So for example, the availability, how portable is it, how recoverable, this might be more dependent of who is serving or the ways that the portal is serving you the files. And so whenever we're talking about data sets, we will be getting, in at least in our case, we will be laser focused on inherent data quality. And data quality is composed of several characteristics that are accuracy, completeness, consistency, credibility, and currentness. And for each of these, there are properties. So for example, let's say I'm going to go with a date, maybe one date. If we are talking about accuracy, syntactic accuracy means, does this date conform to a standard? Is this in maybe in Spanish regional settings or regional configuration, or does it adhere to US standards for dates? Whenever we're talking about semantic, we are talking about, does this thing look like a date? For example, if I have a column of years and inside the column of years there is a month, this is kind of a semantic inaccurate finding, because I'm expecting to find years and then I find something that is absolutely different from years. So for each of these, there are some metrics to record and there are things that you can calculate. For example, are all the records in? Are all the values complete? Everything that can be measured. We need to keep this in our head, because whenever we're measuring, this will help us to define and find out if you are completely measuring the quality or we are missing some aspects. So what is the process like to define data quality? The process basically goes to, number one, define what are the requisites. What do I need? And this is kind of an example here. We have a screen. Each user account in the bank will have an associated one or more IBAN accounts. So every single account will have this. And from this business rule, there are some data quality requisites, like IBAN. Like, I mean, every account will have an IBAN that must not be non null. Every IBAN number has to be well formatted. So for bank accounts, it might be like, for example, our requirements. Whenever we're dealing with this, we just define the data requisite, then we find out the data quality requisites. And these two are different. The first thing it was the what is the business asking for, and the second one is to what extent this requisite is fulfilled. Maybe uh, all the IBAN numbers have to be well formatted, but maybe at least 95%. This is something you have to figure out, and this will help you that just to create your rules. Last but not least, what is open data? All this time I have been talking about open data, so let me do a brief introduction. According to the Open Data Handbook, open data is data that can be freely used, reused, and redistributed by anyone, subject only at most to the requirement to attribute or share alike. So it's like Creative Commons for data. It's like a data that you can get, you can kind of reuse for whatever means you want, and the only thing you have to do is attribute where is the data coming from. So for today, we are going to be using Toronto open data datasets. So in the last 10 years, the growth of datasets available at the Open Data Portal has been kind of, you will see here on the screen. For the 10 years ago, there were like 100, 1,000 datasets. We are in the 72,000 dataset. And in European Union, there are more than 1.5 million datasets that you can get for free and you can use for all your projects here, or your project or your business, whatever. You're not limited in terms of what to do. The main problem is that on this first decade, quantity has trumped quality. So most in several cases, you go to the data set and then you say, oh, this is not what I was expecting. And this is kind of a problem. But the main issue with quality is that the data quality depends on purpose. So maybe the publisher said every single date here we have on screen has a proper date. So it's perfect for me. If you are coming from a Python point of view, you might be saying, no, every single date is different. It's a different format. I need to no, it's not right. The data quality is super poor, but it's kind of a different way to, to see the same data and have different opinions. And it's the product owner, the one that determines what are the rules. So what we will see today, Great Expectations, will help us document and validate our expectations about the data. Okay, in terms of data quality, there are some pioneers, and this is the reason I have like pushed forward to use Open Data Toronto as our example, and they publish for every data set and data quality score. What is the data quality score made of? So it's made of usability. Do the columns have names that resemble the content? Metadata, what percentage of the metadata is completed? Is it really fresh? If the data has been published recently, there are no nonce registers in the dataset. Everything here in this formula can be calculated, and whenever we are going to get a data quality score, we need to find out what are our weights, what are going to be the different values we're getting into, and then calculating them. And the weights are absolutely dependent on what is the purpose. So in this case, for example, Toronto just ran some sessions with their users, with the stakeholders, and said, what do you care the most about in our data? And they created this formula and then applied it to every single data set in the portal. So you might be wondering, okay, but you talk about pandas, and why pandas is not the solution? Well, in my opinion, pandas is part of the solution, but it's not the whole picture. There are a lot of steps before you go into the pandas route, and we will going to see these steps right now, because in the end, what we are trying to do is not just fixing the file I got. Our goal as users of open data should be to have the file fixed on the serving end, to have your city councils, your countries, your regions publish data in the correct form, not just fixing what you got as a download. So let's go with the hands-on part of the session. We are going to figure out how do we validate single datasets. What do we mean by a single dataset? I'm trying to point that whenever we are accessing a portal, we might find, for example, yearly reports of accidents, and every single year we'll have a different data set. So whenever we are trying to validate one of these single data sets, we're going to try to figure out if the quality of the data set included in this individual file is good enough or not. And I just choose one kind of randomly that was not too complicated. That is the bike theft. And this data set is going to help us just to figure out where were the bigs stolen, which models, what were the locations, and everything in between. So this is the one we're going to use right now, and this is kind of the workflow we are going to go during the session. We are going to start by defining some data requirements or data quality requirements. We are going then to create our expectations. Then we are going to validate if the data fulfills our expectations. If it doesn't fulfill them, we will create some pandas function just to recover the files and to create this variation. And then we will just improve the validation based on feedback. So, for example, if we detect that there is some problem with a particular column, we will just fix the column. And if we find something that is still wrong or still broken, we will kind of start the cycle again. We will redefine the requirements and then go ahead with the expectations. So if you have any previous questions from here, it's time to open your notebooks. There is this single data set IPython notebook that we are going to use. And I just want to caution you, because we are going to go through the whole process. And the first step is to go. Do you know Angela Lansbury? It's very famous, like Jessica Fletcher from the series A Crime She Wrote, where she was kind of a detective. So whenever we're trying to approach this kind of open data set, we need to change our mindset and go into detective mode. Like, okay, let's see if this is what I expect it to be. Everything is going to be usually much more complex than you're expecting, even in this gold data set. And I'm going just to show you in 1 minute. But yeah, let's go with this kind of detective mode. And the first thing we need to do is just to explore the data domain. If we are checking about bike theft, because maybe I'm really concerned, I just bought a new bike and I want to know in my city what are the spots that maybe are more dangerous for my bike to get stolen or whatever. Let's say I want to analyze this data set. So the first thing is going to learn about the domain. What kind of information is available? What kind of things do I need to know? What kind of, what's in the files? And then we are going to perform a exploratory data analysis. So for this thing, we are going to be using our web browser, but also one of my favorite libraries. It's called SweetBees, and it creates a really nice report from our data. For those that are familiar with libraries for exploratory data analysis, you might know about pandas profiling, also known as white data profiling. And I have used that extensively in the past, but some of the latest version were not compatible with the latest version of Python. And some of the parts that were compatible with expectations are compatible with older versions of with expectations. So in order not to complicate it too much, we're going to use SweetBees, that maybe is not as full feature as pandas profiling, but it will perform really well for our use case. So let's go to our browser and find out. And let's keep this in mind. Don't trust anything beside data. You know, the house doctor that say everyone is lying, everybody's lying. It's kind of, yeah, technically it's not lies, but usually you read things and you might wonder, okay, is this what I expected or not? And usually there are things that are not really clear. There are some updates that might not be there. There are some obsolete text. There might be missing files. There are all kind of things that might be broken. So with this in mind, let's just go ahead and visit this Open Data Toronto. To visit the website, we open this Open Toronto CA catalog, and this is kind of the place where we can find most of the datasets. There are 465 datasets found, and if we need to find, for example, the bicycle, we just write here bicycle, and it will just return like bicycle post and ring location, parking, where are the racks, where are the, okay, as you can see, there are a lot of data sets. You can see which of them are retired or which of them are not. So here we have the bicycle thefts. Let's explore this page for a moment. Here on the left, we can see the data quality score that is gold. It was the refreshed 2 weeks ago. It's refreshed once a year. It's a map that deals with public safety, and it follows this kind of external information. So we can see that this is published by the police, and you can find here the contact information. And it's time to read about this information about the dataset. It says that the dataset contains bicycle thieves occur by reported date, and details regarding the stolen item were available. This includes all the bicycle thefts reported to Toronto Police Service, included those where the location has not been verified. So, for example, if the airport is not inside the Toronto city and someone reports to the police that their bike was stolen, there will be data about the bike theft in the file, but the coordinates might not be there. And also, it's another very interesting things is that the fields that have been included are for the old city structure, the Toronto City neighborhood structure, as a new one. And something to keep in mind is that just to keep the privacy of the people being stolen, the bike location have been some kind of anonymized, and they are offset to the nearest road intersection node. So even if the bike was stolen at your house, it will not label your house as the place where it was stolen. It will just say, okay, this intersection is where the problem happened. So we might not have really accurate things. The main problem here may be houses that are near one of the division or neighborhood borders. So maybe the bike is reported in the other district or the other division or the other neighborhood, and the house is actually on the other side of the road. So it's not 100% accurate, but okay, that's something just to consider whenever we are reading about this. So this is kind of the data preview. We can see like here really big concentration of bikes. By the way, I just realized that the city airport is here. Never been to Toronto. Maybe in some way I will be there. But so here we can find information about the metadata. These are the data features. This is the offense date. This is the year, the month, the day of the month, the date of the year, the report month. This is kind of the metadata. Where did this happen? This is the division for the police division where this happened. What time did the report happen? Where it was stolen? What kind of premise? What kind of location? What make of the bike? There's all kind of information available here. And if we check here, we can see that what I talked before, the data quality score, how do they calculate this? So if we go down here, we can see like, is the data set up to date? We can see the metrics here. The metadata is well described. The accessibility is not okay. Is there's missing data there? There's no missing data. Well, maybe, who knows? we will check this out. Never trust whatever. I mean, we should trust them, but we will find out. So if we would like to download the file and just proceed, we can just click here on CSV format and click download. This could be a way to go ahead. But most of these portals offer also an interface called CCAN, so you can like explore the data and click it here to visualize the file, so you can kind of preview what is available here on the file. One thing that is very strange, even though we've seen in the description that it was checked for missing values, and it said no missing values are available, the file is 100% complete, we can find here some columns that have a lot of blanks. And if we scroll down, yeah, there are tons of blanks. And even these are supposed to be, let me just scroll this a bit for you. These are the dates, and I assume that we are not getting reports of medieval times bikes. So there is something strange with this dataset. But anyway, this is kind of the first exploration. I'd like you to whenever you are approaching, just take your time to go through the metadata, to go through the description, and if there are tools available to do some preview, that's perfect. Okay, let me just move to the right hand side here and do some here in the geometry field. We can see that this field is the one that is keeping the locations, and based on the what we've seen before, we can see here at grid as map, this seems to be well positioned, because as we can see, most of the data here is based on the Toronto area. If we kind of zoom out a bit, we will see that we have no reported bikes anywhere around. Most of the geographical data seems to be on place. We can even cluster this data to get a better view of what are the most troublesome areas that seem to be near here, the airport area. Anyway, we can explore the data afterwards if we want to. But right now, the things we are going to do is we are going to move to VS Code, and we are going to explore the data set just from the beginning. Okay. If you're not able to follow right now along, don't worry, you will have time. You can just take a look to in a more relaxed pace afterwards. So no worries. So first thing we're going to do, we already did this, is to create a virtual environment and then activate the virtual environment and then install the requirements. In terms of requirements, what we are going to use is Suite Bees for exploratory data analysis, Pandas for obvious reasons, IPy just so it works really fine and fancy with VS Code, then a Grid Expectations library, Black for just formatting, so it looks like I don't have to worry about the formatting. And if we need to download a file, usually we will use the request library, and we will use the Open PyXL and XLRD just to open Excel files in case we are not able to use the regular files. So let's just go to the single data set. I want to make sure you are viewing the screen properly. I would like to know if you can confirm, because I see it a bit dark. Oh, okay. I see some hands. Okay, maybe it's just me that I'm see like a bit. Well, okay, a lot of time. So thank you for your. Okay, perfect. So time to move ahead. So, like I said, if you want to run this on Colab, you will just run this like open Colab and just paste the URL and the thing. The main caveat is that you will need to create the data directories, and you will need to wget the file we will be using, as it's not imported automatically into Colab. So let's start by the beginning. Let's just do the simple thing. Let's just go ahead and I'm just going to select the virtual environment. Let's hope everything works as expected. As you know, this is kind of the demo effect. And here we can see kind of the first registers that, according to what we've seen before, it looks quite interesting. I mean, we have the event unique ID, we have the theft under, we have the date. There are a lot of nuns here, you can see. The year, month, day of the week, day of the year, everything there. So let's just do some this is kind of first step we can do with pandas. And if we see here the results, for example, for OC date or for OC report date, out of the 34,000 registers in these particular fields, there are 5,700 registers that are not null. So that this means around 28,000 of these registers are null. I'm not really sure how you can calculate 100% completeness when your data has like 80% missing values, but that's it. At least you might get 90% or whatever. So we can see all the previous dates. We see like the dates are imported as objects. So we are not getting this datetime object because we of course in our pandas import was not kind of the best. We could have specified the data types and that, but we are not going to do this in pandas, but in the grid expectation software. So let's start by performing a brief exploratory data analysis using this SweetBits library. It's really simple. You just need to import the SweetBits and then you pass it the data frame with the analyze method, and then you just use the show HTML to get the report. So usually this will pop up in a new window, and I'm going just to copy and paste it to my browser so we can see it on the screen right now. This will help us to do some very basic but very interesting. We can see, for example, here the association between variables. Everything is kind of included by default, and I think it's really interesting. We can see like some relationship between the variables. Let's focus right now on the. I'm going to make it a bit smaller so maybe you can see it like you can see it better. Okay. So here on the screen you can see for every single value you have the number of values. You can see here the number of distinct values for example, the IDs. Every single one of them is different, and if you click in any of those, you will get on the right hand of the screen more detailed description. So for example, for event unique ID, here we start discovering very strange things. We were talking about this detective mood. We have a variable called event unique ID, and this event unique ID, if we come here to the bike thefts and check the metadata, we will see that event unique ID is the number of the offense. Okay, so if we come here to the report, we see that there are some event unique IDs that are used 14 times. So this is like very strange because I expect the event unique ID to be unique. We will explore. We need to keep this in our mind to say, okay, why do we have a unique ID that is used multiple times? We need to just go there and find what's happening in the data. If we go, for example, to the OCC date, then the missing values are around 83%. This is quite high, as we knew. Then we need to just focus on the year. We see the year values used here on the right hand side. We can see like the. Let me just move this here, and then here we find another very strange. Let me just see if I can. So, okay, in our dataset description, we got this. If we go there to the metadata or to the description, this says the dataset contained bicycle thefts occur from 2014 to 2020. Then we go to the actual dates, and we see that this is 1975, 1983, 2009. What are these values here? Why are we finding these kind of values when they shouldn't be here? At least this is what we get from the description. So if we move ahead and we can go and report year, report month, let's just go down to the division, for example. These are like the police division. We see like most of the crimes or the thefts happen in 2 or 4. This might be really useful to create some kind of visualization. And then let's see, another thing that just stacks to my mind is like, here I see, right, I'm not expert in bikes, but it seems like a very common maker brand is OT, UK, GI, other, and maybe OT stands for other, and there are unknown make. What we start digging into the columns, and then we need to figure out, okay, there are 180 missing values here, but I assume the missing values are unknown makes because this is the make columns. So it's a bit strange. At least we need to find out what's happening here with the model bike. I'm not even going to enter into the speed or the cost of, but here, this is kind of the first vision. I just go there, and on my first view, what do I see? I see that there might be some issues on the data that is presented here. Okay, there's some people commenting and some people offering feedback. Thank you. If you want to also ask on the Q&A, okay, I will. Some people say, I cloned the project and then created data quality environment. How do I marry this? I think if you want to do it with Conda, you need to get a Conda environment and then just install the requirement using pip, and then open this using the local tool you have for Jupyter notebooks, maybe your IDE. I don't know if you're using JetBrains or you're using VS Code, then double clicking that. And usually in VS Code or JetBrains, you have to select the virtual environment you are using. I don't know if any other of the other attendees maybe can also help here in the chat. So that might be really helpful and really useful. So let's go back to our VS Code, our Jupyter notebook file. So as we were browsing this, I was like, maybe there is some extra information because there are some things that are not very clear for me. Unfortunately, here on the own data set, there is this more information. So there is always the need for more information. Let's just try to find more information. And this is where this kind of can of worms opens, and then you are like, oh my God, I cannot believe this. Yes, this happens all the time with open data. So this is a map with the location. It's kind of the same map that we've seen before with all the 34,000. And well, this is in Spanish. I assume if you are opening that up, I'm going just to paste it into the chat so you can also browse it and not just see my screen. Maybe you also want to browse same time as I'm doing. Here I can click on the view all details, download. If I click here on the download file, I will just let me just go back to a second to the place where we were before, because here we can see like fields have been included both in the old neighborhood structure as well as the new. If I go here to the metadata on the data features, where is the neighborhood information? Is missing. So in the description they say, oh yeah, you can get the neighborhood data. There is no field for the neighborhood data in our file. This is very strange. I want to open the file and double check. Maybe there is no information for real. If you have cloned the repo here in the input file, bikes folder, bicycle thief CSV, you can check this file. And if we see on the first row what is the information available, it actually fits the description of the metadata. I mean the data features, but there is no information about the neighborhood. So if I want to present and I want to analyze what neighborhood had the most kind of thefts, I'm not able to do it because this information is not here. But, and here comes the surprise, if I go to this additional info and just check kind of what are the available files, if I click here on the download file, I will get another data file. And this is very strange because public safety is publishing another file. And this other file indeed has the information about the neighborhoods. You can see here it has information about the neighborhood, it has information about the different districts, it has additional columns. But talking about additional columns, it has additional columns here at the beginning. What are these kind of coordinates? I don't know. This is not either documented here on the website. So it's very, very strange. So what do? We read a lot. And then if we come here to the, let me just go back to a second to the previous site. I mean, public safety data portal. Okay, let me just go here back for a moment. If we go here to the external link, this link is the map. You will soon discover that there is another website for the public safety data portal where they have the documentation. So it's really nice. They have a document and they have a code sheet. So if you look here in the document for bicycle, oh, this is the information I'm looking for. Okay, this is the file. Where is the X and Y column? I don't know. It's not here. So it's kind of undocumented. It's very strange. It's very, very strange. And if I click here, I'm like, oh, this is very nice. They are doing some documentation for me. They are doing some data visualization. Oh yeah, this is super nice. Now I can check all this open data. And if I click here on the description, it's like current year to date is not available for download. But yeah, the data is here. I mean, this is kind of year to date. And this is here on the panel. And maybe this is even in the data. So what I'm trying to say, I'm going to sort this out, is that whenever you're approaching open data, even if it looks neat, even if it looks clear, usually there are so many things going around. There are so many interesting bits and pieces, and you will need time just to do your homework and figure out what are the required data. Indeed, if you look about this data, there is this code sheet that has the code and the meaning for the values we might be seeing. So UK is not a brand of bikes, is like unknown value. And unknown is unknown. And well, this might be helpful. And the bike types are codified, either the bike makes are codified. So it might be very useful just to go and say, okay, this is what I needed. Once I have this, it's going to be all a piece of cake. No way. This is open data. We need to, yeah, it happens. We need to just, there are so many pieces, moving pieces, departments, city councils, everything moving around. We need to figure out our way through this thing together. So let's go and check the data set, and let's define what have we learned in these last 10-15 minutes. So location has not been able to be verified, so the coordinates may be outside of Toronto. The fields have been included for the structures. We've seen that we have a dataset that has this information. There's no personal data. We see that the claim for the thefts has expanded, so we assume that text is not current. And if we check, even if we check the columns of both files, as you see here on the screen, there are different columns. Most of the columns are the same, but there are some columns that are different. In this particular table, you can see the difference. I didn't do this by hand. If, by the way, if you paste both of the columns to GPT-4 and say, what is the difference between these two data set definitions, you will find it will offer you very interesting insight. Even, even to say, that in the original descriptions, the descriptions are wrong. I mean, this just stuck me the most. If we go to the original open data set and we look to the data features, I mean, we are not robots, we are not AI, but maybe we overlook this. This is the day of the year the offense happened. This is the day of the month. No, this is not the day of the month. This is the day of the week. There is no day of the month. So the day of the year is this one. This is the day of the year, and the day of the year is the day of the week. So even if the data is okay, the description is not okay. So if you are trying to automate this, you will get like crashing again and again with this kind of inconsistencies, even in the best, most reported and most looked data sets in the world. So, but still we can improve it. That's what we're trying to do here. So let's not lose our minds, and let's move back to the alternative data set. Let's do a brief exploration of the alternative data set. Let's just, okay, it looks nice. They're the same. Oh, take a look to this. The OCC date is okay. There are no nuns here. There are no medieval times. This is nice. We have here the times. That looks nice. This is an improvement. And even here we have the oh, the neighborhoods. So it looks really nice. Even though there is a column that has duplicate information, it looks really nice. By the way, the longitude and latitude is not the same even for the same registers, and this is based on projections. This is Web Mercator coordinate. Anyway, let's try to, if you run the report, you will see that this file is much more better than the one we found before. But this is not going to be the case, that we usually get one data set, and if that fails, you get another one. If usually this is like one of a kind. So let's see. What do we learn here? There is almost no missing valuables in the data set. That's very nice. And even and there are some duplicates. Yeah, the data is definitely better. By some reason, there are most of the occurrence date happens at night, and I just wonder if Toronto has a really active night, or maybe this is kind of database labeling event that just happens over time. Yeah, division has also a value like NSA. I assume it's a national security agency. It's more like maybe not associated. We don't know. It's not documented anywhere. So what do we do now? Let's figure out if in our actual data, we can just start mixing Python and pandas here. So for example, if we want to visualize where is the occurring date, we'll see like most of the offenses do not happen at 4 or 5. Rather, they happen during the afternoons. So I assume there is some kind of weirdness happening there. We will just sort this out. So if we pack or unpack some of these duplicate event unique IDs, we will see that there are 14 bikes stolen at the same time. Maybe they took a truck and stole a lot of them, so they get them under the same umbrella. We don't know. Every single occurrence here has actually the same unique ID, but if we take a look to the bike details, they are different. So without this information, we don't know. There are some different values, there are some different brands, there are some different speeds. They are not definitely the same bike. So we are going to enter into the grid expectation time. And then the first thing that we need to do is like find out the plan part. We need to plan our observation. What are we trying to achieve? What are we trying to get into? And the first thing we need to do is go back for a second to the slides before we go further, because one of the most confusing things that happens in the grid expectation times is that setting up the environment is a bit complex. So let me just, before I go back to the grid expectation, what are we going to measure? What are we trying to achieve? What are we going to use grid expectations for? After our exploratory data analysis. We have accuracy that says date should be in the correct format. Bike brand should be either source codes or brand name, not a mixture. We shouldn't have like other OT, unknown UK. No, either one or the other. Then we have completeness, consistency, and stuff like that. So let's go back to the slides for a moment so I can just share with you what are the things that, okay, what are the expectations. Grid expectation is a library that enables you just to, instead of using this kind of df is null sum that gets the values, the total summatory of the null values, you can just expect the column values not to be null. This reads much more better and it's much more simple to follow along. So grid expectation enables you to write these checks. And one thing to consider is that grid expectation is great to validate your data and document your data, but it's not, it will not fix the data problems for you. You need to do it by in your on your own. Okay. So the main idea is that you can connect to whatever sources you have. Okay, whatever sources you have, and then I see that someone has just replied on the Q&A. So thank you, Damian, for the step by step. It will be great for people following along. So the main idea is with great expectations, you have your data asset in whatever format and source. Maybe there are database tables, maybe there are FAT files, there are Panda files, whatever you need. And then you're going to get the data documentation and the I mean, high quality data. This is the main idea. And you get some features to get alerts in your Slack or emails, whatever. What does expectation look like? This is just a Python function that looks like this: spec column values not to be null. The good thing is you see down there in the bottom, you see that this same expectation works with Pandas, Apache Spark, SQLite, PostgreSQL, MySQL, Microsoft SQL, Redshift, BigQuery, Snowflake. So the same expectation can be used to check your data with Pandas. Now that the data is imported into some other source, this will be checked for you. The grid expectation has several execution engines, and you can just make sure that if this is like supported, it will choose the right backend to run your query. And if your SQL uses null or your Panda uses none, it will get the same result because this is kind of one abstraction level on top. So good thing is that the at the grid expectation gallery, if you go to gallery.gridexpectations.io, I will just open it up in a second, you will find 324 expectations written for you. Most of them are available just for Pandas. So if you see like the compatibility, most of them are kind of suited for Pandas, but there are lots of them that are kind of can be used for your cloud data warehouses or whatever you are using for. So this is kind of the workflow we are going to run through in our notebook. We are going to install grid expectation. We already did that indeed with the when you are installing the pimp install for the requirements, it will work for you. Then we need to set up a context, and then we start like setting all these things. This is maybe the most complicated part of grid expectation, wrapping your mind about the way that this was set up. But I think once we go through, you will get the point. So the first thing, we have a data context. So and on the broader level, this is the umbrella for you to put on top of everything that is related to a single topic. So in this case, our data context will be related to bike theft. But if you have like several different servers, connection tables, sources, you could have several different data contexts. Once you have a data context, you need to define the data source. And this might be very, very common for data engineers and people working with databases. This is kind of a very common thing. Then you need to say, okay, this is my source. Okay. So usually for SQL servers, it's just your connection string. And this is, I mean, basically, this is built on top of SQL Alchemy. So if it's supported by SQL Alchemy, probably it could work also with grid expectations. But the good thing is that you are saying, okay, in this context, my source of the data is going to be this particular server. The most strange part is that for pandas, instead of having a server, you have a folder. So you can have that in a bucket, you can have in an S3 bucket, in a GCS cloud, whatever. It's going to be the folder. And the folder is going to be the instruction for the data source. Inside each folder, you can have one or more files, you can have one or more tables, and then you're going to have to map your assets. And the main idea about the assets is that you are going to be able to say, okay, this is my asset. This is like for this part, out of this folder, just get these 2 or 3 files, and it will like just get it right. So next thing you need to do is to slice your record, and this is where things get complicated, because so far we've seen like, okay, we need a source, we need, out of the source there are several assets, and then we are going to create like a batch asset that is going to take a slice of this data. So let's say you have a table with millions of records, but you only want to retrieve the latest one. So you might be saying, okay, this is the latest, this is the table, and just get the latest X. I think the new point. Okay, okay. I got my message like, this is your 30-minute warning. Okay, perfect. So this is where the data lives. These are my slices. And then what else do I need? I need my expectations. So spec column values to name regex. This look like really, if you expect column values to match a certain regex, you know what you are kind of trying to match here. Expect column values to be unique. Right, okay, it can be read properly. So you get everything you expect for the data under a suit of expectation. This is kind of the bigger level abstraction, like an expectation suit. And there are 2 ways to validate. One is to use an interactive validator, where you say, okay, this is the data, these are the expectations, figure out if they match each other. Or if once you have everything ready, you can say, okay, I'm going to take this expectation to production. So whenever I run this checkpoint, I want you to check this batch information against this suit, and then get the results. And if things get really wrong, and if something happens, just run these actions. So these are kind of the way that we evaluate that. And out of the whole process, you will get HTML docs that is kind of a report of what happened, did it work. You will get plain HTML files that can be saved to a local folder. Okay, so I think we got most of the things covered. Let's go back to the code. First thing we do is to just create this kind of data context here. Then you go to connect to the data source name, and then you say here, okay, I'm connected to this data folder that is the data input bytes. Here in our case, it's data input bytes. Here I have my CSV files. Okay, so next thing I need to do is I need to say, out of all the files here, just pick this file. Here you can do like monthly files, yearly files. I'm just getting one single file, but you can work with several files. That I think that's very, very interesting. Then I'm going to say, okay, get the whole content of the file and save it as a batch request. So this is kind of the in-memory contents of the file. Under the hood, this is just calling pandas. Here, I don't know if you've seen here, we are like creating our data source, adding a pandas file system resource. So this is kind of the folder. And then we are going to create one expectation suit to serve as umbrella for all the configurations and checks we're going to go moving forward. So here we have that. And then we need to create a validator. Like I said, validator is an object used by grid expectations just to check in an interactive way if the validations are okay or not, or if the expectations are okay or not. And you will see here the expectations in a really clear way. So for example, let's go with the first. Once we have the validator object, we can start testing the expectation. So for example, I'm going to test if the event unique ID column is all unique. And here we can see like, oh, sorry, if you skip one of those, you're dead. So if we click the button here we can see the results, and we see in the result that the result is false. So it didn't fulfill this. I expected the column values to be unique, and it said no, it's not. That's not correct. Out of the 34,000 rows, we got 6,700 rows that are not unique. So this is kind of 20% of the whole data set, and these are all the rows that did not fulfill your expectation, that did not as validate. So there are no missing values here, and the total for this is like 20%. So think about a file that is created every single year, and this is like, okay, if the number of the percentage is over 30%, I want to get a warning. Otherwise, it's kind of normal. I can use a keyword called mostly that can be just used to evaluate if this is correct for 80% of the resources. So let's say I'm allowing this to fail for up to 20% of in total. So it's passing now. Okay, here you can see success equals true. I'm assessing this column ID, and I know that 20% of the resources are not unique, but other than that, this is passing. Let's check if the division values start by D, because I've seen there before that every single division started by D, and it looked like it should start by D. I'm checking this. Oh, it's not. Okay, now you know the drill. It's like, okay, it's not that the values are not matching this regular expression. I'm getting 110 errors. It's 0.3%, and this is my list of values. Okay, given I'm doing this kind of interactive run by, then I can just update this. I'm going here to update my regular expression to be NSA or any digits. So again, I'm going just to check this out. Now I'm getting it right. Everything in the file is either starting by D or is NSA. Of course, you can find alternative regular expressions. Now we go with the big issue. Okay, we had the bike brand or the bike makers, and I'm going to create a list here with all the brands in the file. These are all the brands that appear in the file, and even I'm going to create a dictionary, so I get all the either Acqui or Aquila, Barletta, all these kind of brands, so I can check using this expectation, expect column values to be in a set. I pass the column and I pass the list, and it's going to check if every single row is in the list. Otherwise, it's going to throw an error. And it says no, out of the 32,000, 24,000 of these are not in the brand makers list. Okay, I'm going just to find out if at least they're using the source codes. No, 57,000 of these values are not either there. Okay, this is getting quite complicated. Let's see if I merge both the source codes and the maker codes, I'm getting better results. Yeah, I'm getting better results, but they're like around 9,000 registers that have other values. So I'd say you would need to spend a lot of time to get this right, to get this without any kind of problems. It's like you just check your assertions in a really methodical way with really simple to follow along sentences, so you can validate every single time. Every date should be in the correct format. Okay, here I'm just saying expect column volumes to be date util parsable. So here I'm using the date util library to see if all the dates are correct. And yeah, all of them are correct. Wow, that's very nice. even though if I check here on the lower part, the missing count is 28,000. So for the items that are there, they are compliant with they are complying with this kind of particular rule, because nuns seem to be also parsable. They just, in terms of returning none, they return not a time. So it's kind of a pain. So as I just know that there was some issue there with the dates, let me just say, if all the resources there are between 2014 and 2023, I go ahead and check it out and I see it false. There are resources for other years. Most of them are for 2013. Okay, we are doing this in an interactive way. We can just change the way we're measuring out. So we see that there are 10 values that are outside of the scope. But let me just check for the report year. It seems it's true. So all the report years are between 2013, 2023. So when someone said, okay, this data is between these two dates, it's not talking about the dates, about the offense, but the dates when it was reported. So someone in 2023 reported that their bike was stolen in 1975. This is very strange, but it might happen. And let's make sure we don't want to have any columns, date columns with non-values. So we are going to check that. And if we get the results, we've seen like, okay, out of these 34,000 elements, we are getting these 28 errors. Now that we have set up everything we want to try, now that everything is kind of settled in stone and I'm keeping the latest version, I'm just going to save this to a checkpoint that is going to create a long-term validation where I could like throw actions and fix things. But to make it simpler, I'm just going to save the expectation suit, and then I'm going just to run my checkpoint. This is going to calculate all the metrics, all the expectation in all the previous data. And then we have here a way to build our data docs. And here we get this URL. I'm going to open this up for a minute. This is what we are getting. So here we can see this is our local documentation. If we click here, we can see the option, we can see expectation, and I can see out of all the expectations that were evaluated, 5 were successful, 4 were not. And I can see here this very nice report, like for example, for event unique ID, there are some unexpected values. For the OC date, there are like, for example, there are parsable by date util, but there are a lot of nulls. So this is kind of my report. And then I'm going to use pandas just to fix all these problems, or I'm going to do my best. So here, I'm just going to copy the data file. I don't want to overwrite any initial file. I'm just going to create a new data frame, and I'm going to make all the changes. I'm just going to check to see, for example, here I have other, unknown, UK, all these kind of different values. So I'm going to start by fixing the bike brands. I'm going to fix what's happening here. I'm going just to replace the, using the dictionary, I'm going just to replace the short codes with the long form. And I'm going to see if this looks a bit different. Yeah, now I have this other brand that was split into OT and other. Now, for example, that has consolidated. So I'm trying to fix at least the brand. But if you take a look to the data, there are like e-bikes, there are a lot of other values that are not really nice. Other thing I could do, given that there are 180 missing values, and I don't know what is the make, I can just fill those with unknown make. So it will be more consistent that with what we've seen before. So here I'm going to try to fix the dates, and I see Mauro asking what is the format of date that it validates by default. That expectation just uses the parse date utility of pandas library, but the main issue here, if you want to set to a certain format, there is a validation that you can pass a string format and it will check against whatever string format you want. So you can, here we are just creating one ISO 8601 formatting. So what we are trying to do is to create the OC date by converting the year, the month, and the day to strings, and then just getting them together. And boom, we just discovered that the months are not in the particular format. So we are just going to, again, create a dictionary and do the mapping. And then boom, all our dates are not in the medieval times, are just in normal times. They're like more recent dates. And we've solved two things here. We have filled the blanks, but also we have overwritten the ground dates. So we are using pandas to make the best out of this situation. We are also going to do that for the report date column, so we get everything perfectly fine. Now, what's the next step? We had two data sets. We have two things to fix. What do we do? Well, if it was me, I wouldn't use the file with the medieval times. I would just use the better quality data set from the start. But given we are just trying to find our ways, let's go ahead and do some manual fixing here for your enjoyment. We are going to split the columns that have neighborhoods and its neighborhoods, and yeah, this is the kind of, it has the code and the description. So I'm going to split that into two columns by using another formula. And yeah, what's the point right now? We are going to mix everything together. We are going to create a unified data set, and this is going to be so sweet. What do we need to do now? We have changed everything in pandas. Everything is sorted out. Our file should be better. Do not trust anything, even myself doing this kind of data quality checks. Let's go to the final validation. Okay, this is what we have here. We have already defined our context. We have our expectation suit. This is what we want to test against. What do we need to do now? Okay, we need to import the new CSV file with everything changed. We need to set this as an asset. We need to retrieve the contents, and we need to check against as a checkpoint. We are going to do this in a single step, as everything is here described here. And the good stuff and the good part, the best thing we got out of this, we go to the final point where we create another checkpoint, and we can compare different runs in our context. We've seen before that the docs are inside the context. So if let me just, okay, where is my I'm trying to speed up, as it's not, I'm not sure it's resulting in much more comprehensible talks. So, okay, here we have our expectation results, and we can see that our results are the original test and the fixed test. The original text or the original test had 9 expectation, 5 successful, 4 fail. If I go back here, I check here, I have 9 expectation, 7 successful, 2 unsuccessful. So if I go down here, I will see, like, for example, now I don't have any null values for my date. And this is interesting because we can keep track of how we go forward and how we improve our results and how we can just document what are the expectations about our data. So what have we learned in this run with a single file? Reports will keep track of the improvement, will help you get better results. Maybe it doesn't fix everything. For example, the bike brands will require a lot of time just to get everything perfect, but just figure out what do I need to improve so it's useful for my project. And also make clear that whenever you need to communicate your requirements, other people will be able to help you and assist you because you have that documented. So I'm going just to, there's another part that will take like hours just to I would just realize afterwards like how to work with long-term files. And I'm just going to say that long-term files is like how do we get files together? How do I get several years into a single data file? It has its own set of challenges, but there are kind of basically three problems. Like data grows over time, so the headers are not consistent. Here you can see kind of the step you need to remediate this using grid expectations. And just to uh, ask some questions, I will just go to the end of this multiple dataset files, and I'm going just to present you some examples of expectations, real expectation that can be found in the real world when, for example, analyzing public contracts in my city of Madrid. So, yeah, you can see here some expectations like you can have the values to match a particular regular expression. You can have check if values are unique, if they are parsable, if they are parts of a set, if they are, if the here we have been talking about column expectations, but there are also table expectation. You can see if the name of the columns over the years have changed. You can see if all the files are the same or not, and you can do this in a programmatically way. So that's kind of, I don't know if there are some particular questions. I think I have answered some of those during the presentation. If you want to ask, um, I know we are okay. Just to wrap up, a few years ago, Haldy Wigman just presented open data about tidy data and how to sort these things out. So everything that moves your data to this kind of final version where everything is separate, every row is different, it's an observation, every column is available, there are no messy things, there are no mixed things. It's going to be um, perfect. And yeah, all the materials are there. I don't know if there are some questions. I've seen some of the comments here that people thought that it could be really useful to validate the format. Mauro asked, is it able to validate big files? I would say yes. I think that part of the uses of this solution is integrating with BigQuery, with Redshift, with all these kind of big data warehouses. So yeah, the performance of course depends on the backend, but I'd say the library is quite performant. But again, usually I'm mostly dealing with this kind of smaller files coming from open data. But yeah, I think that it will work. Of course, if it's super big file, if it's like real time streaming data, maybe there are some scenarios where it doesn't work, but there are others where it kind of excels doing this. Um, yeah, this kind of validation. For me, the most interesting part regarding to open data and why I chose open data for this presentation is that whenever you're having a conversation with a public body, uh, it's like everyone has different expectations, and if the expectations are not written down, it's very hard to see if everyone is talking about the same things. It's like it's not really simple to say, oh, the data quality is very bad, and they will say no. Why do you say that? With this tool you can say, okay, I'm checking this thing, I checking that thing. um, and again, I'm going back to the root cause. I hope this video makes its way to Toronto open data administrators, and eventually they fix the issues with the data set, or just talk to each other and say, okay, maybe it's a bit confusing to have two files, or maybe there's another way so we can update the metadata so it's get like really updated on time. So I don't know if there are some particular questions for all of you. I see Gabor here, Maro, Alessandra. I would like to thank you all for coming. Okay, how can we collaborate to test with a big file sending our feedback? I don't know, Maro, if you could like expand your question a bit. You would say, how can we collaborate to test with do you mean sending your feedback to the Great Expectations team? One of the well, okay, I haven't talked about this, but usually Great Expectation has a very active Slack channel where people hang out and talk about how to get started, how to try things. There are a lot of people trying this with Snowflake, with Amazon WS, and all these providers. Even Great Expectation is now providing their own version. And there is also a discourse platform like Discord, Great Expectation. Yeah, and I will go back to Eric's question in a moment. But I will say hang out either in the Slack if you want more active communication with other people. And if you want long-term communication, there is this discourse place for conversation. Eric is saying, can we write custom complex expectation? Yes, it's really kind of really simple. Well, more or less simple. If you go to Great Expectations site, like Great Expectations dot, okay, let's go for a second to docs, Great Expectations.io. If you go here, there is this create expectations, how to create custom expectation. There are some templates for columns, for batches, and for column pairs, like to check if one column is like another. And the good thing is, if you want, for example, to create a column expectation, here you have like a quick start guide. It's like you get a template and you start from there. You kind of customize the way it's called, and then you save it to your plugins file, and it gets imported whenever you want to run. For example, I created one that is have the column names to match a particular regular expression. So I haven't presented the expectation gallery, but here you have, they're like core. These are the, if you see some of those, some of the expectation that say this is like kind of core expectation, like this is like supported, like this is like contrive column aggregate expectation. This is a custom function. This is a function that just comes into the regular grid expectation file. So you would see like there are around 85 core expectations and around 2,500 created by the community. So I'd say it's not complex just to get your own expectation created. Once you wrap up your mind around this concept of validators and all the logic involved, I think it's really, really, yeah, nice just to get started and to create your own custom version and maybe share them with the community, because this is part of the value of being able to work with open source solutions. And like I said, here you can also filter by the kind of maturity status, experimental, beta, or support. You can also check of the kind of the contributors, the items. You can see here pandas is kind of the most supported, but for all of the others, there are a lot of support too. So thank you all of you. One last question on the Q&A. Okay, it was Moses saying, "If you have any question, please write them down here on the Q&A question." I think we are running out of time. I like to thank you a lot for coming to this presentation. I hope it sparked your interest, that it got you engaged and involved in data quality in general, just to find out what's wrong with the data. Sometimes it's not really simple to put it into words, and with these expectations, it makes more simpler to communicate, to document, to validate, and everything done with Python. So I think it's a really worthwhile tool to try. And yeah, let's move to our better quality in all our data. And if you want to keep in touch, um, I'll be here on the Hermit platform for a while. And yeah, you can just contact me, and I'll be really happy to get in touch with you. Thank you so much, Tis, Eric, Mauro, and also Donovan, and all the people at PyData that has been supporting, and Moses. I'd like to thank you all for your time. And let's keep on enjoying this PyData Global Conference. And see you soon on the PyData Global Meetups everywhere.